today's lesson, we are going to look at sectional views. So a sectional view is basically a view obtained by imagining that an object is cut through by a knife or by an imaginary cutting plane and removing a portion of that object that is between the observer and the cutting plane so that we can see the interior details of that object. So here we have a normal object that looks beautiful. Now this object has hidden features inside it that we cannot see. So from the outside, it just looks like a normal object. It is only when we cut it that we can see there is actually more to this object than we see from the outside. So that is what sectional views are used for. It is used to show the internal part of the object which cannot be seen from normal views such as the plan, the side view, and then the front view. So why do we need sectional views in the first place? So the first reason is it is used to reveal internal features that cannot be seen from outside the body. Also, sometimes when we draw objects, we have so many hidden lines that we cannot see or we cannot tell which hidden line is what. So it is used to reduce the number of hidden lines in a drawing. And it is also used to make drawings easier to read because there are no more features that are hidden from the viewer. Also, it can be used to simplify complex assemblies where we have parts coming together and we don't know what is happening inside that assembly. So we cut part of the assembly to see how the objects or how the parts actually fit together. Then the last one is it is used to improve the communication between engineers and manufacturers or any other person who is reading or looking at that particular object. Now once we are doing sectioning, let's look at what a cutting plane is. So a plane is basically like a paper. So a plane can be used to show where an object can be cut or to show where exactly we want to see the internal parts of that object from. So in most drawings, you have a plane that cuts the object. You have maybe alphabets that show where the cutting plane starts and ends. And then you have a direction or an arrow that shows where we are supposed to look at the object from. So in our example here, what they are saying is we should cut this object into two. Look at it from the direction or from the arrows that has been shown AA, and then show the parts where the knife or the cutting plane went through and where the cutting plane does not go through. Then we also have what we call hatching or section lines. Now section lines indicate the material that has been cut. Or let's look at it in a simple way. When I take an object and I cut it through a certain line and I view the object from the direction given, hatch lines are used to show where exactly the cutting plane touched the body, and where the cutting plane did not touch the body, we do not hatch. Then let's look at some types of sectional views that we can have in engineering drawing. We have what we call the full section. A full section is usually applied to symmetrical objects, such that we can cut through the object and get two symmetrical halves. So a full section is just like looking at half of the object, and when a cutting plane goes through that object, what are we going to see from a certain view? Then we have a half section, which actually takes half of the object and then cuts that half into two. So indirectly, it's like looking at quarter of the symmetrical object. Sometimes one cutting plane cannot show all the internal features, so we use what we call the offset section to cut through the object by using a cutting plane which changes direction that passes through several important features, so that we can see all the hidden features or most of the hidden features at the same time. Then for a broken out section, only a small area is broken away to reveal internal details. Sometimes those details are so small that we don't need to section the whole object. So we just break a part of it to show that there is a hidden detail at some part of that object which cannot be seen. Then we have what we call the revolved section. So this one takes a cross section of the object and then rotates it so that we see what the object actually looks like from one end. So when we look at the three objects, they have the same look from the front. It is only when we look at a cross section that we actually see one is a hexagon. So revolved sections are used for structural members and prisms to show their cross-sectional area. The removed section is just like a revolved section, but this one is not placed on the object. The removed one is removed and then placed somewhere else so that we can see what the cross section of that object actually looks like. Before we start sectioning or putting some hatch lines on certain objects, let's look at the rules that we need to follow to do a very good sectioning. So we have the first one, which is we shouldn't draw hidden lines unless they are absolutely necessary, because we want to keep a clean view. The sectional view is just supposed to show which parts of the object was actually cut by the cutting plane and which ones were not cut by the cutting plane. The second rule is that all cut materials must be hatched so that we can see which parts are actually cut and which parts are empty. Rule number 3, don't leave things hanging. Indirectly, we should join parts to make sure that they are part of one object. The moment you don't join them, then they look like they are different objects that are hanging. Rule number 4, we cannot use hidden lines to enclose a sectioned area, or we cannot have an empty space where there are sectioned lines. So ensure that a sectioned area is always fully enclosed by visible outlines and never by hidden lines. Rule number 5, we must use different angles or patterns to section different parts of an assembly. When you have only one object and you are sectioning, you can use just one pattern or only one hatch type to section the cut face. However, when you have different parts that come together, we need to differentiate them by changing the pattern or by changing the angle of the lines, just to show that they are different parts and not the same object. And a very important rule, that if there is an object that has been cut, so far as it is a single object, then there shouldn't be another object on that cut face. But what we are saying is that a visible line should never intersect a sectional area in a view of a single part. So then what is a rib? A rib is a thin, flat projection added to a component to just increase its strength and stiffness. It doesn't add to the weight of that object. Now, what are the rules that we follow when sectioning a rib? When the cutting plane passes along the length of the rib, we do not hatch that rib. So although the cutting plane goes through it, the rib is not sectioned, because hatching it would make the rib appear thicker than it actually is and could mislead the reader or whoever is reading about the shape of that component. However, when the cutting plane cuts across the rib, it is hatched to show that it is now part of the structure. So if it goes through it, it is too thin to be hatched. If it goes across it, then we hatch the rib. Apart from ribs, there are also components that we do not section in assembly drawing. Some of these components are screws, pins, shafts, bolts and nuts. We have keys, washers, rivets. So some of these things, we do not section them because of the nature of how they are. Some are very, small objects, or they are just fasteners that we don't need to section.